The Milky Way is one example of a galaxy, and the nearest galaxy to us is the Andromeda Galaxy. We think there are about 100 billion galaxies in the visible universe. The Andromeda Galaxy has been instrumental in reshaping our understanding of the universe and our place within it. For instance, while the closest galaxy to us is Andromeda, we estimate there are about 100 billion galaxies in the visible universe. This discovery provided compelling proof that the universe does not revolve around Earth. It shattered the notion that the Milky Way was the sole galaxy in existence, suggesting that we're just a tiny part of the vast universe. Our knowledge about Andromeda has grown over the last century, primarily through observations made on Earth. However, with advanced tools like the James Webb Space Telescope, JWST, now at our disposal, our perspective has drastically changed. Unexpectedly, recent information from the JWST has challenged our previous notions concerning Andromeda, presenting another cosmic puzzle to solve. The JWST has received unusual signals from our neighboring galaxy that have left the scientific community astonished. Join us as we look into how the JWST received an alarming signal from the Andromeda Galaxy. The evolution of our understanding of the Milky Way. The perception of the Milky Way has evolved significantly throughout human history, influenced by our advancing understanding of the cosmos. In the past, when our technological capabilities were limited, the Milky Way appeared as a hazy band of light across the night sky, evoking a variety of interpretations and mythologies. It was often seen as a mystical and central element in the cosmological beliefs of different cultures. In the 1920s, American astronomer Edwin Hubble made a transformative discovery using the 100-inch Hooker telescope at Mount Wilson. Through his observations and analysis, Hubble revealed that distant nebulae beyond the Milky Way were actually distinct galaxies, each containing billions of stars. One of the closest of these galaxies was the Andromeda Galaxy, also known as M31. Andromeda has a long and varied history, with observations dating back centuries. One of the earliest known records of this celestial object can be traced back to the Persian Empire in the 10th century. The astronomer Abdul al-Rahman al-Sufi described it as a small cloud in star charts from that period. The significance of these observations lies in the fact that al-Sufi was able to locate this distant cosmic entity without the help of telescopic instruments, relying solely on his keen perception and observations. In 1612, a more detailed description of the Andromeda Galaxy, based on telescopic observations, was provided by Simon Marius. His work laid the foundation for future astronomers to study this massive cosmic structure. In 1764, the renowned French astronomer Charles Messier designated the Andromeda Galaxy as M31 in his well-known Messier catalogue, erroneously claiming its discovery despite Simon Marius being aware of al-Sufi's earlier records. Nevertheless, Messier played a significant role in bringing Andromeda to wider attention. For almost 100 years after this, astronomers worldwide worked to gather more and more information about this enigmatic galaxy, each building on the findings of their predecessors. Contributions of early astronomers. Before these discoveries, the Italian astronomer Galileo Galilei revolutionized our understanding of the Milky Way in the early 17th century. Using his newly developed telescope, he made groundbreaking observations that challenged the prevailing Aristotelian cosmology. He discovered that the Milky Way was not just a diffuse band of light, but a massive collection of individual stars, planets, and other celestial objects. Through his observations, he demonstrated that the Milky Way was not at the center of the universe, as previously believed, but instead a vast expanse of stars scattered throughout space. In 1750, English astronomer Thomas Wright put forth a novel hypothesis about the universe. He speculated that the Milky Way was not a random distribution of stars, but a structured, flat layer. He also suggested that a portion of this vast structure contained our own solar system. While Wright's hypothesis was a step forward in comprehending the structure of the Milky Way, it remained constrained by the limited observational technology of the time. At that time, most still believed that the Milky Way was the entirety of the universe, a belief that, considering the limitations of technology, was not surprising. A significant leap in understanding the nature of the Andromeda Galaxy came in 1864, when English astronomer William Huggins made a groundbreaking observation. He studied Andromeda's spectrum and noticed that it was different from that of a typical gaseous nebula. This discovery paved the way for scientists to understand Andromeda for what it truly is, a galaxy. Understanding Andromeda today. The mass of Andromeda is estimated to be between 1 and 2 trillion times that of our Sun, making it an enormous cosmic structure that happens to be relatively close to us in the vastness of space. Based on research conducted so far, scientists believe Andromeda is about 10 billion years old. Its ancient age hints at a long and intricate history of formation and evolution. One of the most interesting hypotheses about Andromeda's origin suggests that it formed through the merging of several smaller proto-galaxies over billions of years. This theory implies that smaller galactic entities gradually combined under the force of gravity to form the majestic Andromeda Galaxy we see today. Such galactic mergers are common occurrences in the universe and play a crucial role in shaping the growth and structure of galaxies. For a long time, astronomers believed Andromeda was significantly more massive than our own Milky Way galaxy. From Earth's perspective, Andromeda appears so large that it was easy to assume nothing could rival its size. However, galaxies are immense systems, and their mass is intricately linked to the distribution and movements of stars, gas, dust, and dark matter within them. Pinpointing the precise mass of a galaxy requires sophisticated observational techniques and meticulous analysis, something that could not have been achieved in the 1700s or even the 1800s. This type of knowledge requires modern instruments, and only now are we truly beginning to understand the reality. Recent research has resulted in a new assessment of these beliefs. Scientists have slightly reduced their estimate of Andromeda's mass while simultaneously increasing the estimated mass of the Milky Way. As a result, the current understanding is that the masses of these two cosmic giants are much closer than previously thought. So, if you were standing on Andromeda and looking at Earth, you would see a galaxy just as massive. This perspective helps illustrate the colossal nature of the Milky Way. The Andromeda Galaxy itself is physically immense. However, its exact dimensions are a topic of ongoing study. It is widely agreed among astronomers that Andromeda's total size surpasses that of our own Milky Way, with a significant diameter of approximately 220,000 light-years. This exceeds the Milky Way's estimated diameter of approximately 100,000 to 175,000 light-years, making Andromeda a truly significant cosmic entity that occupies a vast region in space. This revised perspective also highlights the complexities and difficulties in accurately measuring the mass of galaxies. At the heart of the Andromeda Galaxy, a supermassive black hole exerts a tremendously powerful gravitational pull on the surrounding stars. These stars move around the black hole in elliptical orbits, much like planets orbiting the Sun in our solar system. At a certain point in their elliptical paths, stars reach their closest approach to the black hole. This is called the perihelion. At this point, gravitational forces are at their strongest, causing the stars to move at their highest speeds. As they bunch up near the black hole, the stars release radiation in the form of energy, including visible light and other types of radio frequency energy. This increased concentration of stars and radiation results in a bright, observable region in the galactic core of Andromeda, known as its active galactic nucleus, AGN. An AGN is a highly energetic region at the center of a galaxy, characterized by high emissions across various wavelengths, from radio waves to X-rays. AGNs are powered by the presence of a supermassive black hole at the galaxy's core. These black holes are incredibly dense regions in space where an enormous amount of mass is concentrated in a very small volume. Using high-tech telescopes such as the Hubble Space Telescope, astronomers have observed a fascinating phenomenon in Andromeda's AGN. It appears to have 2 points of concentration. This means there are 2 distinct regions where light and other forms of radiation are emanating more intensely than in the surrounding areas. One of these points is slightly offset from the true galactic center, where the supermassive black hole resides. The mass of Andromeda's supermassive black hole is estimated to be between 1.1 and 2.3 times 110 to 230 million solar masses, meaning it weighs hundreds of millions of times more than our Sun's supermassive black holes are believed to be common in the centers of galaxies, including our own Milky Way. As a result, they play a crucial role in the evolution and dynamics of galaxies. When matter, such as gas and stars, gets too close to a supermassive black hole, it forms an accretion disk. This disk of swirling material heats up and emits intense radiation across various wavelengths, which is why AGNs are highly luminous. Observations of Andromeda's AGN reveal a particularly bright point of concentration near the central supermassive black hole. This feature results from unique gravitational interactions between the black hole and the surrounding stars. Andromeda also has another fascinating feature: an abundance of globular clusters. These star clusters are tightly packed groups of stars that orbit the center of the galaxy, much like satellites revolving around a planet. Andromeda is estimated to harbor around 460 of these dense, ancient clusters, each containing hundreds of thousands to millions of stars that formed at roughly the same time. The incredible number of globular clusters in Andromeda provides valuable insights into its cosmic history and interactions with smaller galaxies over billions of years. This suggests that Andromeda has actively absorbed smaller galaxies in a process known as galactic cannibalism. As these smaller galaxies come within Andromeda's gravitational reach, immense forces strip them of their stars and other components. The stars from these cannibalized galaxies become part of Andromeda's stellar population, adding to the rich diversity of stars within the galaxy. This characteristic of accumulating globular clusters and absorbing stars from smaller galaxies is typical for spiral galaxies like Andromeda. Spiral galaxies, characterized by their disc-like shape with distinctive spiral arms, provide an ideal environment for interactions and mergers with smaller companions. In addition to its other intriguing features, recent observations suggest that Andromeda may be undergoing a significant transformation. It appears to be transitioning from a typical spiral galaxy to a relatively rare type known as a ring galaxy. Ring galaxies are unique and relatively rare celestial objects, characterized by their circular or elliptical ring-like structures. These rings consist of bright, young, blue stars, while the central region contains comparatively little luminosity. These distinctive features make ring galaxies stand out among the vast array of galactic structures. There are three main types of observed optical ring phenomena: nuclear rings, inner rings, and outer rings. Nuclear rings are found close to the center of a galaxy, while inner and outer rings form farther out. Additionally, there are two primary types of ring galaxies: O-type and P-type. O-type ring galaxies have centrally located nuclei, with smooth and regularly shaped rings. P-type ring galaxies have off-center nuclei, with rings that tend to be more irregular in shape. Ring galaxies are considered rare cosmic gems, with only about 1 in 10 galaxies classified as such. Astronomers have proposed two main mechanisms for their formation. First, they can form through the collision of galaxies, where one passes through the center of another, triggering the formation of a ring-like structure. One well-known example of a ring galaxy formed through such a collision is the Cartwheel Galaxy. Andromeda and the Milky Way are on a collision course and will eventually merge to form a new, even larger galaxy. This colossal event has already earned nicknames like Milkomeda or Milkdromeda, as it is known worldwide. However, while these nicknames are playful, the consequences of this merger for humanity remain uncertain.